We're living in a world of plastic, so learning to fix it is super helpful. What if you could bond plastic together super easy and permanently using red-hot staples? You're not going to believe this plastic welding tool that I found. It's cheap, it's effective, and I never knew it existed, and I wish I'd known about it years ago. And of course, while we're there, we're going to take a look at what's inside of the plastic welder tool. We're going to measure its output, and then I'm going to show you the long-term results from 2-year-old repairs. It's a really neat tool for cheap money to have in your toolbox for those times when the plastic on your lawnmower, wheelbarrow, car bumper, or whatever splits and you want to stop it from spreading. And before I forget, please, please, please like and subscribe to my channel. It's only one click for you, but it means a world of difference to me. I'm trying to get my first YouTube milestone of 500 subscribers on my path to becoming a professional channel. A couple things to note with the stapler, right, are that it uses a high current to make this piece of wire super hot. Low voltage, high current. This has some sort of transformer in it that lowers the voltage that makes it super high current. And I'll show you that in a little bit too on the meter. The other thing to note is if you take these staples and you just jam them all the way in, they're really tight to remove and the plastic gets soft. So I like to just put them in so they're just barely touching because they'll melt their way right in. So here we go. I'll try to manually tighten it down as much as I can on this very first one. Once I can figure out the angle that gets me a really nice tight seam. We'll get the thing super hot. As you can see, once it starts to glow, be super careful because it really is super, super hot. The next trick is don't push it all the way in because it will push through to the other side and just leave you with a hole. So I'm going to let that cool for a second. I pull it out and I've already got a pretty strong steam. There's a bunch of different staple types. I'll show you those in a few minutes as well back on the bench, but this is probably the one that I think offers the most force or the most strength because the other ones are straight and I don't want it to pull in the plastic. So I give it this wavy line here. So let's go ahead and put another one in. Again, this is one of the super cool tools. You'll see there's little holes in here to put the pegs to the staples. And they do sell, you can buy just the staples so you can replenish your kit. So for a seam like this, it's going to be under high stress because we know the trashmen are not kind to your trash cans. There we go. You can see the smoke burning off the metal. The metal's super hot. Just push it in a little. Turn the power off on the trigger. Let it cool before you pull it out because you pull the staple out at the same time. Oop, like that. Exactly. I'm going to give it a little more heat. I've got to reset it because I messed it up. Okay, there we go. There's another one in. Again, we're just going to show this. A couple of these being put in. We'll go back on the bench in a few minutes and we'll show you what's going on inside, the voltages, the currents, talk about some safety things. But first we're just going to make this one seam here. As you can see, we've got the staple plugged in. I'm going to push the trigger. I'm going to pull the trigger on this, which will turn the light on. Make the staple super hot. We'll put it in. Sometimes I don't just keep it held down the whole time. Once it starts to melt in, I'll just give it a little shot. Then hold it in place and don't move to the best of your ability until the plastic has cooled down around it so you can pull the staple out. So I'm going to just hold this here. I'll put a little pair of pliers in here so you can see it a little better when I cut. Try to get as flush as you can. And then as you see, I just cut these little stubbles off. I've got 6 of them in this case, plus the ones that we had on the inside. Again, can't stress how important it is to put a staple ahead of where the crack is in the non-cracked area. Otherwise the crack will continue to spread and you'll try to stop it. Now even though I've cut those off super tight, you can kind of see there's a little stub on there and they hurt. They're super sharp. They will cut you up. So we'll go ahead. We're going to use my grinder tool, but with a piece of sandpaper on it, and we're just going to sand it down. Just double check things here for smoothness. And yeah, it's not going to cut me now. So just something to be aware of. So we're going to head over to the workbench now, and we're going to take a look at what makes one of these work. And I do dare say, let's take a look and see what's inside. But first we'll go over some theory. We'll measure voltages and current to see kind of how this works. As I said earlier, please, please, please subscribe if you can. World of difference to me. I am trying to make this channel become a professional channel, and I need 500 YouTube subscribers to meet that first tier, and then 1,000, along with all the watch hours. So this is a typical kit. We'll start with probably the staples here. They give you 4 different types in this kit. And again, you can buy more of these. You have the squiggly line, which is what we just used. Take a look in there. They're all squiggly. So I got a little magnet on here. Let's see if they're magnetic. They are not magnetic. Interesting. So they are a stainless steel of some kind, I think, but they're actually pretty good. So 0.8 millimeter wave staple, a corner staple. I have yet to figure out how to use, but I would assume you jam it into, if you have something wedged together like this, you'd jam it into the corner, but even on that big recycling bin, I didn't bother using it. The straight staples, which have a little bit of wave in them, but I like to have more wave so that I have more, you know, if it tries to pull apart, it's stuck in there. And then this outside corner staple, and again, I didn't use those either. And this one's actually a thinner diameter. They do get stuck together a little bit here. This outside corner staple, if you can even see that. All right, so we got 4 different staple types. Again, you can buy more of them. They do give you a set of cutters, which is great. They're not, I mean, these are low-grade cutters. They give you, in this case, they give you this melting tool so that you can use it to smooth plastic around, along with a bunch of plastic chunks that you can kind of cut off and melt into your thing to make it smooth on the top. And finally, this cutting tool. I guess it's probably for scraping. I don't know. I've never used it. It's here. I have my own cutters that I probably prefer better. But to be honest with you, the thing that probably helps the most is having a file so you can file down the burrs. In my case, I dispensed of that, and I just used my rotary tool because I happen to have one. But you don't need to have one. But I would say a file or some sandpaper or something needs to be included in this kit. Oh yeah, and before I forget here, they also include a piece of mending cloth. So you could sort of melt this into whatever you're doing or Bondo it in, and it gives you some support, and you can cut that in along with some directions. But again, this isn't necessarily a review of the tool. I just want to show you the power of this tool and how useful it is just to have in your plastic arsenal. So we're looking at this plastic welder, and the question is, how exactly does it work? We put a staple in here. Got one of my straight ones here. We plug it in here very carefully. It is electrical equipment, so always use caution. It is offshore electrical equipment. I do have it plugged into a GFCI, but we are going to take some voltage measurements here in a few minutes and some current measurements to see what's going on. But I'm going to push the button here, turn it on, I'll watch it light up and get super hot. So that is glowing red hot. Do not touch it. You have heat and you have electricity here. Those two things can be quite dangerous. We'll use a steel pan in here. I'm going to pull it out, plop it in there to cool off. This particular unit plugs into 120 volts AC. So right there, use caution. I would not use this in the rain or outdoors. It is an electrical device like anything else. So just use caution. We're going to take our meter here. I'm going to turn it on. And we're going to see what's going on inside in terms of voltage and stuff. But we'll just start out with, so I've connected up my fluke meter. We're on the AC setting, and we're going to pull the trigger and see what happens. That is 2.2 volts, only 2 volts. So 110 volts AC coming in, 2.2 volts going out. Let's take a look on the DC side. Maybe it has a bridge rectifier or diodes in there to convert it. Let's take a look. Nothing. You can see the lights on, and I'm still getting 0 volts here. So it definitely is just probably a big transformer in there that converts 110 volts AC to 2 volts DC at high current. We'll check that current here in a moment too. All right, this meter is only capable of measuring 10 amps. We're not going to blow the internal fuse on it because I can already tell you that in order to make this thing work, they have to pass high current. They have to pump out high current, and that's why they drop it all the way to 2 volts. So 2 volts times 10 amps, right, is what? 20 watts. I think this thing was rated for 100 watts. Does it say? Power 100 watts. So 100 watts divided by 2 volts is 50 amps. So let's take a look. Is it really putting out 50 amps? This meter can only do 10, so we're going to use a clamp meter. And then we're going to pass current through this solid copper jumper wire that I made. I have 40 amps AC and I have 400 amps AC. And we know we're dealing with AC because we measured it. So we'll stay on that and we won't try to move over to DC here. So we'll put the clamp meter on. I'll hold it in a safe position. We're not going to keep it on very long, but let's take a look here at how much it goes. Ready? 1, 2, 3. 58 amps. Things are getting hot over here. I can just tell that these connectors are a little hot, but that's 58 amps at 2 volts going through this. So this unit is maybe, depending on the accuracy of my meter, running pretty hot. So it's the current that is actually the thing that melts the wires, not the voltage. I don't know, we made that 110 volts, right? That would be less than an amp going through that wire. So it can handle it, other than the fact that, if you were plugging directly into 110 volts, which would be a really dumb idea, it would trip your breaker, right? It would spike up to 15 amps and trip your breaker. This may or may not get hot, but it's just something to know there. All right, we're going to unplug this, make it into a safe condition here. Remember, if there's capacitors or anything like that in there, they can also hold current. But we're going to make sure that, just to show everybody, we are unplugged. We're trying to be as safe as possible. And I see several screw holes here. So we're going to try, I think they're regular screws. So let's go ahead. So yeah, so we've got 1, 2, 3, 4, 5, 6 screw holes, but we also have this rubber molding on here. So maybe let's just take a look anyway. And let's try to see what's inside a welder. So at the end here, as promised, we'll go take a look at 2 long-term welds, one in a recycling bin, one in a wheelbarrow. And I did try some vinyl siding. I had a really hard time. Vinyl siding is very thin, so it worked, but it kind of burnt it a little bit, and it was really hard to control the depth that you're going at with that. So we're just taking, I should have done this a little more orderly here, but all these screws are the same length, so that's good to know. So just try to keep a handle on that so I know which ones to put back in which direction. That is also the same length. I'm using this Milwaukee M4 screwdriver. So those of you that know the Milwaukee brand will say, like, M4? How is that possible? Well, they made one just for the screwdriver because it's been so popular for them over the years. There it is, M4. All right. We've got that. Okay. Whoa, that just plopped right off. Did not expect that at all. All right. So yeah, this is literally no safeties at all. I don't know the electronic safety parts to this, so just be, don't do this at home. And when you just have a transformer, I don't know how, if you can get current back from one of these legs back to one of these in any serious way. So I'm not recommending or saying anything, but you can see power comes in. One leg goes to this transformer. It's a nice thin wire. Another leg goes to the switch. When you push the switch, it comes out this red wire, goes into a transformer. And it's literally just a transformer. And it's got 2 sets of wires. So I don't know if that's got 2 coils or what. But it's got 2 wires, one here and one here. So I would assume oh, that's what it is. These thin little wires go to the little light that's here. And these thick wires that are coated with some sort of heat-resistant shielding go to these two things, which are the high current probes. So these are the high current leads. So how high quality is this? I'm going to suggest it's super low quality. Your mileage will vary. Be super careful when you use these. They are generating heat, but they're also dealing with electricity. And again, you can see this thing says voltage 110 volts, power 100 watts, output current 0 to 65 amps. And we measured, what, 57, 58 amps? All right, we'll put these back together, and then we'll just go show you the long-term review of some of the welds that I've made with this. And these, so in spite of the cheesiness of this, I like this because it's got a really nice torque setting on it. The torque setting is very accurate. So you don't over tighten your plastic. We're not fixing plastic screw holes today. We're fixing broken plastic shrouds. Okay, so that is what's inside of a Wardsley, W-R-D, Lossy, Ward Lossy plastic welder. Again, I'm not recommending this brand or any other brand. There's a bunch of them out there. They're all over Amazon.com and other locations. I'll put a link to one that I found that had some good ratings. But remember, the tip gets super hot. It is low voltage, but we never know how the voltage will backfeed to the primary. So be very careful. There's nothing in here except a transformer. And that's it. Well, transformer switch and a light. But honestly, the work is being done by a single transformer that allows it to take 110 volts AC. It's probably going at 60 hertz, and 60 hertz, 2 volts AC, 57, 58 amps. We're going to take a look at some long-term fixes here, and this is my recycling bin, and I'll just show you. This is about 2 years old. It's still functionally holding in. You can see it was really cracked. The bin was shot, and I managed to fix it all the way down. And again, I had the one way down there to fix the stop of the crack. It has opened up a little bit over time, but you know, garbage men are not easy on stuff. I may put an extra staple in here at some point, but for right now, it's holding together and they throw it around. The other long-term fix I had, which is actually even more impressive, is I have this Gorilla cart, and it formed a crack in it about 2 years ago, and I've been hauling a lot of dirt in this thing. And you can see right up here where the handle hits a lot, it cracked. And that would have surely kept spreading and caused me to need a new one. And so what I've managed to do here is I just welded that together just like all these others. And you can see it's kind of holding together really super well. I probably need another staple here as well, but this has been 2 years on this. So I've extended the life of this by about 2 years, and you can see what happens is you push on this really hard as you're trying to empty it out. And then finally, we'll head over here to my back garage door. And I used epoxy to fix these originally, and I shoved it in the crack, painted it. It really looked a lot better, but I am going to absolutely get these set, put some plastic staples in them, maybe mold some of the black plastic in, and smooth it out. But you can see it, what an awful job the glue made. So, very unimpressed with that one. So again, if you like this content and want to see more, please like and subscribe. I really appreciate every comment that I get. People subscribing, people liking. Subscriptions are probably king for me right now as I'm a small channel. And I'm trying to get to 500 and 1,000 subscribers, which should increase the content and how and what I'm doing for you guys. But again, I love this content. I love taking things apart. I started this out, I was just going to show you a plastic welder. And then I was like, well, we have to know what's inside this plastic welder tool. So we took it apart. Anyway, that's it for today. Thank you for watching. And again, please like and subscribe. Every subscription, every like, every view hour helps me tremendously. Thank you.